Hey everyone, and welcome back to the channel! Have you ever wondered why your smart speaker sometimes takes a moment to respond? Or why the live feed from your security camera can get a little laggy? You might think it's just your Wi-Fi, but a big part of the answer lies in where your data is being processed. For years, we've relied on the cloud, sending information to massive data centers far away, waiting for it to be processed, and then getting a response back. But what if there was a better, faster way? What if the intelligence could come to you right where you are? Well, there is, and it's called edge computing. It's a revolutionary concept that's quietly changing the world of technology. And today, we're going to break down exactly what it is, how it works, and why it's about to become a huge part of your life. So, let's start with the basics. What exactly is edge computing? Imagine the internet as a giant city. In the center of this city, you have these huge skyscrapers. These are the cloud data centers. They have immense power and storage, and traditionally, almost everything we do online, from streaming a movie to sending an email, involves a trip to one of these skyscrapers. Your device sends a request. It travels all the way to the city center, gets processed, and the result travels all the way back. This is the cloud computing model we all know. Now, edge computing doesn't get rid of the city center. Instead, it builds smaller, local processing centers all over the suburbs and neighborhoods. This is the edge of the network closer to where we, the users, and our devices actually are. So instead of every single piece of data having to make that long, round trip to the central skyscraper, a lot of the work can be done right there in your local neighborhood hub. In simple terms, edge computing brings computation and data storage closer to the sources of data. This is done to improve response times and save bandwidth. Instead of sending data to a centralized cloud for processing, it's processed locally or on the edge of the network. To really get it, let's use a simple analogy. Think about ordering a pizza. In the traditional cloud model, there's only one pizza place for the entire country, located right in the center. No matter where you live, your order goes there. They make your pizza, and then a driver brings it to you. If you live hundreds of miles away, that pizza is going to be cold and take forever to arrive, right? That delay is what we call latency. Edge computing is like opening up local branches of that pizza place in every single town. Now, when you order a pizza, your order goes to the shop just a few blocks away. It's made and delivered in minutes. It's hot, it's fresh, and the experience is way better! The main kitchen in the city center is still there for special orders or to supply the local branches, but the urgent, time-sensitive work is done locally. That's the core idea of edge computing. Reduce the distance, reduce the delay, and deliver a much faster, more efficient service. So how does this actually work in the real world? Let's look at some examples. One of the most exciting applications is in self-driving cars. An autonomous vehicle generates an insane amount of data every single second. We're talking terabytes a day from cameras, LiDAR, and other sensors. Now, imagine if that car had to send all that data to the cloud to decide whether to brake or swerve to avoid an obstacle. The round-trip time, that latency we talked about, could be the difference between a safe stop and a serious accident. With edge computing, the car's onboard computers process that critical data in real time right there in the vehicle. It can make split-scan decisions without ever needing to connect to a distant server. It might still send less urgent data to the cloud for analysis later, like traffic patterns or map updates, but the life or death decisions happen on the edge. Another great example is in smart factories, or what we call Industry 4.0. Modern factories are filled with thousands of sensors on machinery, monitoring temperature, vibration, and performance. In the old model, all this data would be streamed to the cloud. But with an edge gateway on the factory floor, a lot of this data can be analyzed locally. The edge system can predict if a machine is about to fail and alert a maintenance crew immediately, preventing costly downtime. It doesn't need to clog up the internet connection by sending a constant stream of normal. Everything is fine data. It only sends the important summaries or alerts to the central cloud for long-term analysis. This makes the factory smarter, more efficient, and more resilient even if the main internet connection goes down. And it's not just for cars and factories. Think about healthcare. Wearable devices like smartwatches can monitor vital signs. With edge processing, the device itself could detect an irregular heartbeat and instantly alert the user or a caregiver without waiting for the data to go to the cloud and back. Or think about retail. Smart stores can use cameras and sensors to analyze foot traffic in real time, helping manage queues or restock shelves more efficiently. The video data is processed on-site, which is not only faster, but also better for privacy, as sensitive video footage doesn't have to be sent over the internet. Even entertainment is being transformed for augmented reality and virtual reality to feel truly immersive. The system needs to respond to your movements instantly. Any lag can cause motion sickness. Edge computing can process the complex graphics and tracking data locally, delivering that seamless, real-time experience that makes AR and VR feel real. So, let's quickly recap the main benefits of edge computing. First and foremost is speed, or low latency. By processing data locally, we dramatically cut down the delay, which is critical for real-time applications. Second is bandwidth conservation. Since we're not sending huge amounts of raw data to the cloud, we free up our internet connections. This is a big deal, as the number of connected devices, the Internet of Things, continues to explode. Third is reliability. Edge devices can often continue to function even if their connection to the central cloud is lost. That factory can keep running, and that self-driving car can keep navigating safely. And finally, there's enhanced security and privacy. By keeping sensitive data local, we reduce the risk of it being intercepted as it travels across the public internet. Processing data on-site means less personal information leaves your private network. Now, you might be thinking, does this mean the cloud is dead? Absolutely not! Edge and cloud computing are not enemies. They are partners. They form a powerful team. The cloud is still the best place for heavy-duty, large-scale data analysis, long-term storage, and training complex artificial intelligence models. The edge is for the immediate, time-sensitive task. The relationship is... The edge devices collect and pre-process data, sending only the most valuable and relevant information to the cloud. The cloud then uses its massive power to analyze that data, uncover deeper insights, and send updated models and instructions back to the edge devices, making them even smarter over time. Think of it as the edge being the agile frontline soldiers making quick decisions, while the cloud is a central command center analyzing the bigger picture and setting the overall strategy. As we look to the future, edge computing is going to be the invisible engine powering so many of the technologies we're excited about. The rollout of 5G networks is a massive catalyst for edge, as it provides the high-speed, low-latency communication needed to connect countless edge devices. From truly smart cities that manage traffic and energy in real time to healthcare that monitors us 24/7 to immersive gaming and entertainment experiences we can't even imagine yet. Computing is the foundational piece that will make it all possible. It's about distributing intelligence, moving processing power from a centralized, faraway brain to a decentralized network of quick-thinking nerves right where the action is happening. It's a fundamental shift in how we build our digital world, making it faster, smarter, and more responsive than ever before. So, the next time your smart device gives you an instant answer, or you see a drone navigating a complex environment with ease, you'll know that it's likely the power of edge computing at work. It's a fascinating field that's evolving every single day. What are your thoughts on edge computing? Can you think of other ways it might change our lives? Let me know down in the comments below. I'd love to hear your ideas. Thanks so much for watching. And if you found this video helpful, be sure to give it a thumbs up and subscribe for more deep dives into the technology that is shaping our future. See you in the next one!